Guys. So, I understand that we have a test on Module 12, Chapter 12, on Friday. So I thought that we would go through the review. I am on page 393. This is the ready to go on page. Number 1 is talking about probability. So we have Jasu tosses a coin and spins the spinner at the right. What are his possible outcomes? Well, first off, he could toss the coin to heads and spin a 1. Secondly, he could toss the coin to heads and spin a 2. Next, he could toss a coin to tails and spin a 1. Or he could toss a coin to tails and spin a 2. So those are all of the options that he has, because there's only the 2 numbers on the spinner and there's only the heads and tails options on the coin. Number 2, while bowling with friends, Brandy rolls a strike in 6 out of 10 frames. What is the experimental probability that Brandy will roll a strike in the first frame of the next game? So number 2, 6 out of 10. So we set it up as a fraction. We then need to divide out to reduce this fraction. Well, actually, we could end up with 2 different answers, both of which are correct, but I do believe it was always having us use fractions when we were doing this, not the percents. So let me check that real quick. Back at 12.2, it was having us use fractions for it. So we'll just keep it as the fraction. We won't worry about the percent. Okay, so we're going to divide by they're both even. So we're going to divide out the 2. 6 divided by 2 is 3. Over 10 divided by 2, which is 5. So the probability that she is going to get a strike is 3/5. That's her probability. For the next number, number 3, Ben is greeting customers at a music store. Of the first 20 people he sees enter the store, 13 are wearing jackets and 7 are not. What is the experimental probability that the next person to enter the store will be wearing a jacket? So I want to know will be wearing a jacket. It said that 13 of them were wearing jackets and 20 out of 20. So 13/20ths. You need to pay attention to what it's asking about. It wasn't asking who wasn't wearing a jacket. It was asking who is wearing a jacket. Number 4. Auden rolled 2 number cubes and recorded the results. What is the experimental probability the sum of the next 2 numbers rolled will be greater than 5? So we need to see what the sums are of the ones that she's rolled so far. Number 4, 2 plus 3 is 3. 4 plus 5 is 9. 3 plus 2 is 5. 2 plus 2 is 4. 1 plus 3 is 4. 6 plus 2 is 8. And 5 plus 3 is 8. So we are looking for it being greater than 5. That happened 1, 2, 3 times. So it's 3 out of how many tries? 7 tries. So 3/7 of the time. That is the experimental probability that it will be greater than 5. Number 5 says a player on a school baseball team reaches first base 3/10 of the time he's at bat. out of 80 times at bat, how many times would you predict that he will reach the first place? So number 5, 3/10 of the time he does. I don't know how many he's going to this time, but I do know that he's at bat 80 times. Now remember, there are 2 different ways that we can do this. We can first go, what did I multiply 10 by to get 80? Well, I multiplied 10 by 8. Whatever I do to the bottom, I have to do to the top. So that means that x is equal to 24. This one works out really nicely that way. But if it didn't work out really nicely that way, you could have done it this way and it still would have worked. We could have done our cross multiplication. So we end up with 3 times 80 is equal to 10x. 3 times 80 is 240 is equal to 10x. That 10 is bothering the x by multiplication, so we are going to divide to get rid of it. The zeros will cancel out, and so x is equal to 24. Again, exact same answer, 2 different ways of solving it. The way that you choose to solve it depends on whether or not you notice that you could multiply by 8 right away, or if you want, or if you can't tell what you should be multiplying by, you can go to this every single time. It always, always, always works. And number 6, how is experimental probability used to make predictions? Okay. Number 6, experimental probability tells how likely it is that something will happen. Experimental probability tells how likely it is that something will happen. You need to pause to write. Pause. I'm moving on to the back side. Page 394. Consider each addition problem. Is the sum positive? Okay, so if I have a negative 18 plus a positive 27 plus a negative 6, it's been a bit since we've done one of these. Negative 18 plus 27 plus a negative 6. The positive and the negative right here go together to make a negative. So I have a negative 18 plus 27 minus 6. We can go ahead and move things around because of the commutative property of addition. So I can go 27 minus 18 minus 6. I'm going to plug that into my calculator. 27 minus 18 minus 6 gives me a positive 3. So is it going to be positive? Yes, it will be, for that one anyway. Letter B. 12 plus a negative 19 plus a 5. Again, the positive and the negative go together to make a negative. So it's 12 minus 19 plus 5. I'm once again going to move things around so they're doing what I want them to do. I'm going to go, my 12 plus 5 gives me a 17. Okay? And then I'm going to subtract the 19 from that. 17 minus 19 is a -2. That will end up being a negative number. So no, that one is not going to be positive. And finally, letter C is 32 plus a -24 plus a -6. Positive and negative make a negative, positive and negative make a negative. So I actually have 32 minus 24 minus 6, which I'm just going to do exactly. Gives me a +2 as my answer, and so the answer will be positive. I'm not entirely sure why we have that as part of our review for this particular chapter, but that's what it is. Number 2 says the spinner on the right has 8 equal sections as shown. So the probability of landing on an odd number is 1/2. Well, for number 2A, 4 out of the 8 numbers are odd. I can divide out a 2, which gives me 4 divided by 2, which is 2, over 8 divided by 2, which is 4. I can divide out another 2. So I have 2 divided by 2, which is 1, and 4 divided by 2, which is 2, which takes me to 1/2, which is what A was saying that it would be. Letter B. The probability of not landing on 6 is 7/8. There are a total of 8 spaces. 7 of them are not 6. So yes, 7/8 is how many times it would not land on 6. Letter C. The probability of it landing on a number less than 3. Less than 3. What numbers are less than 3? You can't count 3 because 3 is equal to 3. Only the numbers 2 and 1 are less than 3. So that is 2 out of the 8 numbers. If I divide out my 2, that has us down to 1/4. Well, 3/8 is not 1/4. So that one has to be false. Number 3, this table shows the sizes and colors of t-shirts sold at a store in the past week. To the nearest percent, what is the experimental probability the next customer who buys a t-shirt at the store will buy a large blue t-shirt? Explain how you solved this problem. Okay, this one's going to be a bit not necessarily complicated, but long to do. Because the first thing that we need to do is for our numerator, we need to figure out how many large blue t-shirts they sold. Large blue t-shirt says 20. And then we need to put that over top how many t-shirts they sold all together. So I am getting my calculator and I am going over to this chart and I'm going 32 plus 49 plus 28 plus 12 plus 36 plus 20. I am literally just reading the numbers off. I'm typing in every single number on this chart. Plus 20 plus 42 plus 23 gives me 262 shirts that they sold last week. I literally just typed in and added every single one of them. I can take a 2 out of this. 20 divided by 2 is 10. 262 divided by 2 is 131. I cannot go any smaller than that. I don't think I can stress enough how much you really do need a calculator for these ones. Otherwise, it is going to take you 10 times as long to solve these problems. I could have added it all together by hand, but that's 9 really big numbers I'm adding together by hand. That's going to take a very long time to do. Number 4 says, the experimental probability that a delivery service will deliver a package late is 3%. An employee at the delivery service predicts that 45 out of 15,000 packages will be delivered late. Is this prediction reasonable? Okay, so let's figure out how much the actual probability is of this happening. So I have 15,000 packages, and then I am going to multiply it by the 3%. Now remember, I cannot multiply by a percent. I need to change it to a decimal. It always goes over 2 spaces. I don't care how many numbers you have. So I end up with 15,000 times 0.03, which gives me 15000 divided by 0.03. Really? Oh, I'm sorry, times 0.0. I ended up with an absolutely massive number, and I couldn't figure out where I got that from. Times 15000 times 0.03. There we go. So that is 450. That's how much probability says are going to be late. So is 45 even close to 450? No, it's way off. It's off by a good 400. So we would write down that no, because the actual probability is that 450 will be late. So 45 is insanely too low. Okay, so that's the end of the review for this chapter. Good luck. I'll see you later. Bye.